Hello and welcome. My name is Rene Neumann, and over the next few minutes, I'd like to talk to you about how you can use the network automation blueprint to recover FortiGate from a failed firmware update. Let us begin by looking at the environment and then how we can use that environment to enable NetBox to drive automation. We're going to use for that one a Nodegrid Appliance and update a NetBox environment. And then in the second step, we're going to use the entire environment to drive a firmware upgrade to a FortiGate and recover it from a failed state. If you look at the environment, then you will see on the left-hand side a FortiGate branch router, which is connected to a rack PDU. We can use the rack PDU to power control the unit in case it is in a failed state. And additional to that, we have two management interfaces to the FortiGate. One is standard console interface, serial connection, and the second one is an IP-based management interface, which provides us access to the web UI as well as the SSH connection to the device, which we can use to interact with the FortiGate. All of that is terminated on the ZPE Nodegrid service router, which has upstream and access to an AWS environment where we have Ansible as well as NetBox installed as a source of truth. The connection is provided through a pre-existing LTE as well as a VDSL connection, and we use zero-tier as an overlay network to provide a resilient connection to our remote environment. So in the very first part of the demo, we're just going to focus on the Nodegrid and the NetBox environment. And what I really want to show you, why you want to integrate a Nodegrid service router solution with a NetBox environment. So NetBox is a source of truth solution, which is quite common. We have quite a lot of teams and organizations using it. And what we want to do in the very first place is just update NetBox with standard information. I want to show you that you can use Ansible to pull information from a Nodegrid appliance and provide them into a NetBox environment. And we're going to look there at basic details like a serial number, like a firmware version. In the second step, we're going to do the same thing, but with a connected end device. And the goal here is to automatically populate NetBox with necessary information so that we can use it as a source of truth to drive the automation and later to the same device. So namely, pulling management IP address details off the device using console connection and provide them and update them in NetBox. And lastly, then I'm just going to briefly show you that the information are now available and we can just drive automation using the standard management interface to the same device. So let's start with a demo. So let me briefly show you the environment. Here is the Nodegrid service router. Very briefly, that is the web interface. You can see a couple of target devices here configured on the device. FG01 is our FortiGate. What you currently see here is a serial console connection, and here over on this side we have the SSH session and the web UI. For the very first part, we are going to look at primarily these kind of information from the Nodegrid in itself, like the firmware version, like the serial number, and a couple of other details. And the goal really is to pull them from the Nodegrid and populate NetBox with it. Let me briefly show you what we have in NetBox. You can see we have here a couple of devices, but primarily we have the Nodegrid service router here. And as you can see, we have an IP address defined for it, but really no additional details are currently available. And that is really what we want to do now. Let me briefly explain what you see here on the screen. Is on the left-hand side, you see our Ansible controller, and on the right-hand side, you will see then the console output from the FortiGate. So we're going to look at that in a second, a little bit closer. Let's start with the very first playbook, which was really pulling information from the Nodegrid and updating NetBox with it. So let's run the playbook. So what the playbook does, it connects to the Nodegrid appliance using Ansible, pulling some basic system information, making them available as Ansible facts, and then we can use those Ansible facts to update NetBox. As you can see, it just went through everything and automatically updated the details in NetBox. So let me show you what that looks like. If we go now back into NetBox, you can see already the serial number was put in, BIOS version, firmware version, and a couple of other details. But you can go now as well to the config context and see actually the entire output, which was put back as a JSON, if you want to have a reference to what it was before, for example. Now, I mentioned you can do exactly the same thing with the FortiGate device. Let me briefly show you what we have here in NetBox. Pretty much same setup. Nothing is currently configured, but really what I want to point out is we have no primary IP address here currently defined, which is really important to perform any real task on the device using the management interface. So, and we want to rectify that using our Ansible environment. So let me run that playbook. Now, what you will see is exactly the same steps. We will log into the device, pull information back, and then update NetBox with it. But important here is on the right-hand side, you will see now the console output showing up. In the very first step, we just run the command get system status automatically on the end device, passing that information, displaying it here, updating NetBox with it. And in the second step, we're going to do the same thing with the management interface details. And you will see that coming up in a second. So here we already just run the command on the end device. And now on the left-hand side, in a second, we will see how we're updating NetBox with the same details. So that just completed. So if I go back to NetBox and look back at the FortiGate, now we can see here the primary IP address is already populated besides our serial number, BIOS version, and so on and so forth. And if I go to the config context, then you can see very similar to what I've shown you on the Nodegrid, the raw data. So at this point now is I can just run a playbook directly against the FortiGate. The main difference really is that that uses a standard management interface, and you can already see the speed difference because it's just a standard IP-based interface. It's much faster than connecting to a serial port with 9,600 bouts available to you. But the core is it works, it is reliable, and you can automatically update your source of truth system using the serial console interfaces without any major work on your part. Now, in the second demo, we're going to use the same environment, but we want to perform a firmware upgrade on the FortiGate. What I want you to realize here is that the firmware update process is going to use a standard automation tool you have today. There's no change to that part. We just really encapsulated it with the building blocks using the automation framework to create a backup, store the backup locally, primarily pull as well information about the management interface, store them locally so that we can use them to recover the unit, then perform the firmware upgrade as normal, perform a couple of checks afterwards. And then in our demo, we are going to simulate a failure and use the out-of-band capabilities which we have now at our disposal to recover the unit back into a working state. As the whole process would take around about 20 minutes. I pre-recorded it, and I'm going to talk you through the entire steps in this short demo. On the top left-hand corner, you see the Ansible playbook again. Underneath it, you will see the console output, so you will see what we're doing on the end device. And on the right-hand side, just as a guidance, you have the presentation showing you exactly at what step we are. In the beginning, we perform a standard firmware backup, store that locally on the Nodegrid using FTP, as well as pulling the management details back and just store them locally on the Nodegrid as well. And we do that primarily so that we have the information available in case we need it, in case something goes wrong, and we can easily recover the unit. As you can see, we just logged into the device. First, we recovered the management interface details, and now we are performing the backup using an FTP server, which is provided by the Nodegrid as well. After that, we're going to perform the firmware update. We utilize again the capabilities of the Nodegrid to pre-stage the file. So upload it from the Ansible post down to the end device, pre-stage it, and then start the firmware upgrade using the console interface. I could use the same thing using the standard Fortinet interfaces. That doesn't really matter. We just use everything here using our local environment. Now, the cutover was just because the firmware upgrade process takes normally 15 minutes. The unit is currently restarting, and it's nearly done with the firmware upgrade process. So what happens after that one is that we are going to cross-check the device, make sure it's fully functional. And then in our case, we are going to simulate the failover, the failure of the firmware upgrade, and we're going to start the recovery process. So if you look at the Ansible playbook, you see the simulated update failure. And really what we're doing is now recovering the unit by first applying the management interface details again, so that we can definitely talk to our Ansible controller, and we're going to power cycle the device as well. Just because we have heard that from time to time, devices hang due to firmware upgrades or due to any other reason, and it's simple fix in many of these cases might be just a standard restart of the unit to recover, or to power cycle unit to recover it from a failure. So the unit will now restart. Again, it would take a short while. And as soon as that is completed, we will perform another check, see if the unit is now reachable through the management interface. It is, and now we can use again our automation environment to fully reinstate the firewall to its working state. That really completes the demo. Thank you very much for your time and your interest. And if you want to read more about the Automation Network Blueprint, then I would invite you to come to our webpage, zpesystems.com. You will find the blueprint there. On the screen, you have a QR code, which directly brings you to the download page. And if you're more interested in the automation capabilities in general, we have all the examples which you saw today on our GitHub page. And if you want to use them, if you want to get access to them and maybe contribute to them, then just go to our sign up page and we can give you access without any issues. So again, thank you very much for your time. It was really a pleasure talking to you and demonstrating the capabilities to you, and hope you enjoyed the demonstration. Thank you.